Alright guys, here we are exploring the wonderful world of optics. Here we are going to dive into the math a little bit, and I want to go over the rules. So let's do some definitions. So let's say we have a concave, the cave shape, concave mirror. We could also have a concave lens, a convex mirror, or a convex lens. These rules are true or hold for all mirrors and lenses. So they make it really easy. So once you get the shapes down, this applies to all of them. So if I have my mirror, it'll have a focus, of course, and it'll have some focal length. I then place an object, which I will just draw as an arrow. Usually you typically draw objects. You can draw a person. I'm just going to draw an arrow. Not to be confused with the light rays. I'm not going to draw any light rays here. I'm not going to do ray diagrams yet. I might explore that with you guys, but honestly, I think we should just go over the rules of how to calculate things, which I think would be much more beneficial. So we have our focal length f, the distance from the object to the mirror or lens is O. Notice that this is not a theta, this is a cursive O. It's hard to draw small lettercase O, lowercase o without it looking like a zero. So I'm just going to draw a cursive O. I hope that's okay. That's just what I do. I've seen it done like that before. And of course there will be an image. So the image is created by ray diagrams is one way to figure out the image, and should occur somewhere over here or over here. I believe this one, if I'm doing this right, will occur back here somewhere. So we're going to get some image which will be some distance I. So I for image, F for focus, O for object. Awesome. Rule the first. The equation. It does not matter what units you are in as long as all of the units are the same. 1 over O plus 1 over I equals 1 over F. Definitely have this written down. Where F is the focal length, O is the object length, I is the image length. These are all distances from the mirror or lens to the object, image, and focus. These are all distances. They're not heights. So the heights we will label as H sub O and H sub I. Obviously the focus doesn't have a height. So these are all distances. Remembering, of course, that our focus, our focal length is half the radius of curvature. Beautiful. This is everything you need to know. except one little thing which just throws a wrench in all this, which makes it a little more complicated than it needs to be, which is, are these numbers positive or are they negative? I cannot emphasize how that is so important and is the summary of optics and all mirrors and lenses, is keeping track of positive or negative. Here's how you do it. If it's real, and I mean real, meaning it actually exists. If it actually exists, it's positive. In fact, I kind of want to draw that differently. I want to draw that as an arrow, meaning real implies positive, positive implies real. Yeah. And if it's virtual, meaning imaginary, then it is negative. And if you end up getting, for instance, that you have a negative focus, that means it's a virtual focus. Or if you get a negative value for I, it means it's a virtual image. So let's go through the list. Let's start with O. O is always. What do you think? Boom. Why would the object always be positive? Well, and by the way, this is only true if you're using a single lens. There's no such thing as a virtual image. You can't have a not real thing in reality. Everything that you put in front of a mirror or a lens is real. It is a real thing. It emits light of real photons. They do not have to be imaginarily created with dotted lines of imagination or pretend lines of connection. It is a real thing. So O is always positive. If you do have more than one mirror or lens, you can have negative objects, but we are not going to be doing that. So there's no such thing as a virtual object in our case. Therefore, O is always positive. Easy done. Cool. It's easy, right? That's done. Always positive. What about F? F is next. Here's where the last movie, the last video that I showed you is essential in understanding the rays of light and the shape. So concave and convex can either be convergent or what's the other one? Divergent. Remember, convergent is where it actually, in real sense, comes through the focus. So if it's really coming through the focus is real. Ooh, see the connection? So real means actually where the light is. Real means where the light is. So if it's convergent, you have a positive focal length. If it's divergent, you have a negative focal length. I hope that makes sense. So it's just the concept of real being where the light is, the convention of that being positive. So if it's convergent, the light actually goes there. So notice how a concave mirror will have what? Does the light actually go there? Yes. The light actually goes to the focus where the light is, so it's a positive. If it was a convex mirror, the focus would be over here, the light would go this way, it would diverge, so we would say F is negative. That's the easiest way to do it. And last but not least is the image, but honestly for the image you need to just understand this. This is all you need to understand, that if it's real it's positive, if it's virtual it's negative, and vice versa. So if you end up solving for I and you get -2, well then you know it's 2 away, 2 inches, 2 centimeters, 2 millimeters, whatever the unit is. And if it's negative, it is virtual. So here's the only tricky part. I think this is fine so far. The only tricky part is this. If it's real, it's upside down, or we call inverted. If it's virtual, it's upright. So do not confuse the negative value for I. So real meaning, of course, a positive value for I, and virtual meaning a negative value for I. With the positive or negative height. So inverted would mean H is negative. It just means it's upside down. Don't think about it too much. Oops, that's supposed to say I. The point is that if it's virtual, it's upright. If it's real, it's inverted. The easiest way to remember this, it's really easy. There's 2 real life instances where this comes into play. It's obvious. It's so easy. When you look at yourself in the mirror, say in your bathroom. So go to the bathroom or the mirror in your bedroom or wherever you have a mirror, and you look at yourself. Is that image real or virtual? Well, I hope you understand that it's virtual because light isn't actually coming from the opposite side of the wall. It could be anything on the other side of that wall. It could be another room. It could be a vortex to another dimension. It could be the air outside. It could be a closet. But what's for certain is that you are not there. Light is not coming from this side of the mirror. So if an image appears over here, it's virtual, which also means it's got to be upright. And look at that. You look at yourself in a flat, plain mirror, you always get a virtual, upright image. There's no exceptions to this. Cool. Last but not least, I'll give you the final equation, which is the magnification. Which, of course, if your image is larger or smaller, so now we're taking into account the heights. So is it the same height? Do you appear larger or smaller? Clearly in a plane mirror, a flat mirror, you're going to appear the same height. Your image will be the same height, so the magnification will be 1. So the magnification is the ratio of the heights. So it turns out that this, and this is the important part, is equal to the ratio of the distances. How awesome is that? I think that's super awesome. So if it's farther away, it's taller. So by the way, this negative sign just refers to this, where if you have a positive image distance, you have a negative height, which means if it's real, in other words, if this is positive, you get a negative inverted image. So I know this feels kind of cluttered, but this is it. if you write these down in a way that is organized, where you look at real is positive, virtual is negative, there's O, there's F, and here there's I. And don't worry, guys, we will practice this all next week in class, again and again and again. And we'll have lots of fun with real life lasers and images and mirrors and lenses. Thanks, guys. See you later.